Hey guys, I hope your first lesson went well. This is lesson number 2. We're going to talk about dependent events. So, when the outcome of one event impacts the outcome of another, it's called a dependent event. So, we already talked about independent on our last lesson. Probability of A and B, it's the probability of the first event and then the probability of the second event. But dependent is just slightly different. The difference is that with a dependent event, your second probability changes. And so, with those cards we were talking about on the last one, with the drawing the smiley emoji cards, if I didn't replace a card, so let's just say I drew a heart eyes card, and then I didn't replace it, and then I wanted to know the probability of drawing a angry face, my probability would change because now there's only 7 cards instead of 8. So that is a dependent. The second thing depends on what happens in the first event. So let's just talk about the difference between the two. I've got a few examples here, and we're going to say, are they independent or dependent? Flipping 2 coins, resulting in one landing on heads and one landing on tails. If I have 2 coins and I'm flipping both of them at the same time, do they impact each other? No. So that would be independent. Okay. The captain of the football team is selected, and then the co-captain is selected. Think about a football team lined up, and they pick out the co-captain, and then they're going to pick out the captain, and then they're going to pick out the co-captain. Is that second one going to be impacted by the first decision? Yes, because let's just say in my family, if I pick out Logan first, who's left? I only have my husband or my daughter. So that second one depends on the first event, depends on who I pick out for the first one. All right, you draw a joker from a deck of cards, and then you draw an ace. If I draw out a joker out of a deck of cards, has that deck of cards changed now? Yes. And if I'm not replacing it, then the next draw is going to depend. It's going to change because of what I drew first. You draw a queen from a deck, replace it, and then draw a 10. Is that independent or dependent? That would be independent, because if you replace it, then that deck is still the same as it was when you did the first event. So really, you just have to think about the second event and think about, does that affect the first thing? A coin is flipped and a number cube is rolled. I actually talked about that in my first one, my first video. Those are both independent. Flipping a coin and then rolling a dice, that dice does not impact my coin. Those are independent things, okay? So let's look at a couple examples. These are dependent, okay? So Neil goes to a pet shop and selects a treat for his dog. He chooses one and then chooses another. What is the probability that he selects a bone and then a ball? So let's focus on the first event first. How many bones are there? There's 3 bones out of how many total things? 1, 2, 3, 4, 5, 6, 7. So the probability of drawing a bone is 3 out of 7. Now I have taken that bone, and it does not say I'm replacing it. I've taken that bone out. So you can imagine, let me find my little X tool here. You can imagine that I have taken out one of the bones, okay? Well, if that's the case, then now my total number of items is different. The probability of drawing a ball would be 1, 2 out of how many total things? Well, now there's only 1, 2, 3, 4, 5, 6 things. So it really impacts that second event if you're not replacing the item, okay? But then my steps are the same. I still take the probability of the first one and I multiply by the probability of the second one. So my numerators, 3 times 2 is 6. 7 times 6 is 42. On your assignment, you don't have to simplify. I said this on my last video. I'm not counting off if you forget to simplify. But if you do simplify, that would be good. You should, but I'm not counting off if you forget. So 6 over 42, I could divide by 6 on both of those and get 1 out of 7. Okay, here's another dependent event. Mackenzie chooses one candle and then chooses another candle. What is the probability that Mackenzie selects a polka dot candle both times? All right, so in the first event, her probability of getting a polka dot candle would be 1, 2 out of how many total candles? 5. Okay, but then if she has already chosen a polka dot candle, oops, oh, there it goes. If she's already chosen a polka dot candle, then that one's gone. She already picked it. So what's the probability on the second draw that she's going to draw out a polka dot candle? Well, there's only 1 out of how many total candles left. This one is gone because she already drew it. So now there's only 4 options. There's only 4 candles and one of them is a polka dot. And then I multiply. 2 times 1 is 2. 5 times 4 is 20. So I get 2 out of 20, which would simplify to 1/10. Okay? And these will stay on your notes so you can look back at this when you go back to your assignment. Okay? Here's your assignment. It only has 3 questions. I think I'm going to actually fix the way this looks so that you're going to put the probability of the first thing times the probability of the second thing equals answer. So I'll lay that out so that it looks like these. Okay? If you have any questions, you know where to find me. Shoot me an email. I hope that you have a good week. This is our last week of instruction. Yay! Next week, we'll have a quick review on Wednesday, and your test will be on Thursday, okay? And it'll be a Google form, so it should be pretty easy, a test over probability. Bye, guys.